Alright, so for this week's discussion, this is what my prompt says. So it says, you are drawing two independent random samples of men aged 25 to 29. Each sample has size 200. The first sample is a random sample from the population of all 25 to 29-year-old men living in China. The second sample is a random sample from the population of all 25 to 29-year-old men living in the United States. So for my null and an alternative hypothesis, for my null hypothesis, I rejected my hypothesis because my mean samples both equals 0, and for my alternative hypothesis, both means did not equal 0. So, well, both means did equal 0, so that's why both were rejected. But so now I went to this next step, and it says pick the sample size that you want. So I picked 200, and it says pick the first country you want to use in your test, and of course the first one in my prompt is is China, so I picked China, and the second one is the US. So now it gives me my choices, and basically it says to select a new random sample of 1,600 men aged 25 to 29 from this country. So I did that by selecting the country that I picked, which was China. I copied it and I pasted it into my raw data. And then it says the second country, which was the US. So I did the same thing with that, and I copied and I pasted it into the raw data worksheet. So then it says the raw data spreadsheet will calculate descriptive statistics data visualizations. The chi-square spreadsheet will do the calculations. So after I did all of this, I plugged in my data. Oh, there it goes. I plugged in my data for both of those, and it gave me a frequency, a percentage for both countries, and it gave me a histogram for both of those. And for my chi-square, it gave me my observed frequencies, my expected frequencies, the differences between the two, the squared differences versus expected, and my standardized residuals. And it gives me my histogram for both countries combined. And it gives me my degree of freedom and my p-value and my chi-square statistic. So now explaining the independence of both of these men are independent because they are from a random sample, but it is targeted for men aged 25 to 29 living in China and the US. The histogram is bimodal, and randomization occurs because of calculation now. So if you go back to the directions, it says that you calculate now to get a random sample of 1,600 men, which I did that. And so for my results, as you can see, there were, for observed frequencies, there were more United States men ages 25 to 29 that were single versus 64 who were in China. And for married, there were more married men in China than there were in the US, and the US was twice as much as China for divorced or widowed. And for expected frequencies, they thought that it would be equal for both to be single, both to be married, and both to have the same numbers for divorced and widowed. And so the difference between both of those is China has -35 and the United States has exactly 35. China has 36.5, and the United States has negative 36.5. China has negative 1.5, and the US has 1.5. So when you square the differences for both of these, both countries come out with the same calculations, and for the square differences and expected, they both come out with the same calculations as well for standardized residuals, as well as the same thing. So for chi-square statistic, it will be 53.36, and for my degree of freedom, it's going to be 2, just because the categorical variables that I'm working with is single, married, and divorced/widowed. So I'm taking all 3 of those, and I'm taking away 1, which will make my degree of freedom 2, and my p-value is that. So So in this conclusion, we concluded that China and the US, based on my randomization results, China and the United States have almost, if not equal, results as far as being married and single. But for divorced and widowed, the United States have a slightly higher percentage for widowed and divorced, and China is right up under them for widowed and divorced.